Hi there, you're welcome. This is an example on trajectories and orthogonal trajectories, and then I took it from the 2013 May question paper, and that is question 8. You can go try do it and then get back to this video. Okay. Now we're given this this thing here, this vector here as the velocity field given as this here. Okay, and then question A is asking us to find and identify all trajectories. Okay, now we have something like this. Okay, since this represent our dx dt and this represent our dy dt, we can just write it as dx over dt is given as minus 4y squared, and dy over dt is given as xy. So remember, what we need to determine is dy over dx. Okay, so to do this, you're gonna say our dy, remember we're using chain rule, right? So dy dt is xy, and then we divide that by minus 4y squared, which is dx dt inverse. Okay, so know that this y will cancel out the other y and the denominator, and then we'll be remaining with dy over dx is equals to x over minus 4y. Okay, now we need to solve this differential equation. We are aware that we can use variable separable, and that will give us y dy is equals to minus 1 over 4 x dx. Okay, so we integrate both sides. This is a constant, we take it out, integrate both sides, and that will give us y squared over 2 is equals to minus x squared over 2, and that 2 will be multiplied by 4, so it's gonna give us over 8 plus c. Okay, now when we take this x to the left hand side, we're gonna have something like y squared over 2 plus x squared over 8 is equals to c. Okay, and this thing here looks familiar. Remember that we used to have something like last year from chapter 10, when we have y squared over b squared plus x squared over a squared is equals to 1. When b is greater than a, this is an equation of an ellipse, right? And then when b is greater than a, you're gonna have this kind of ellipse, given that b is greater than a. And when a is greater than b, you're gonna have something like this. Okay, so when we check what we are given here is like, we check your a, this here in this case, you check that a is greater than b, so that means we are looking at a curve which is like this. Okay, now that's another, we'll work that out when we have to draw. Okay, so this is what you had to do for part A. Okay, now let's let's go to part B of the question. And then part B it goes on to say find all orthogonal trajectories of this thing here. Okay, so remember we said that with trajectories, what we actually have to determine is dy over dx is equals to minus g over f, where g is this and f is that. Okay, now doing that, we're gonna have dy dx is equals to minus into minus 4y squared over and then our f is x y. Okay, note that this minus will give us a positive, and then this y here we cancel out that y, and then we are left with 4y over x. Okay, and this is dy over dx. Again, we can use variable separable, and that will be 1 over y when you divide both sides by y, dy is equals to, and then multiply both sides by dx. You're gonna have 1 over x dx. Okay, and again we can integrate both sides, and then what we get is natural logarithm of y is equals to 4 natural logarithm of x plus c. Okay, now we have this thing here. What we can further do, remember with logarithms, when you have say x to the 4, you can represent this as 4 ln x. So what I'm gonna do here, okay, when I have this, sorry, when there is logarithm of x to the 4, we can write that as this. So in this case, we're given this thing. So what I'm gonna do, I'm gonna take the 4 to the power of x. So let this be ln x to the 4 plus c. Okay, now let's take ln x to the 4 to the left hand side, and then we're gonna have ln y minus ln x to the 4 is equals to c. One other thing, remember the laws of logarithms. The log of y over x is the same as log of y minus the log of x. It can be natural logarithm or log, it's fine, but the rule remains the rule. Okay, so what we are given is this thing here. So I'm gonna take it into this form. So that will give me natural logarithm of y over x to the 4. Okay, and that is equals to c. Okay, now when we raise both sides when we take exponential of both sides, what we are remaining with is y is equals to x to the 4 is equals to, this will still give us a constant even when we take the exponential of both sides. So let's represent this constant now as a. Okay, so what we find is that y is equals to a x to the 4, where a is a constant. Okay, so this is the answer for part B. Now part C, it goes on to say sketch clearly the trajectories and orthogonal trajectories on the same set of axes. Okay, let me grab a page for that. Okay, now sketching the trajectory, we know that I'm gonna first sketch this one here. So this is what we have to sketch, and we said that this is an ellipse. I don't know I'm writing it correctly, but okay, it's an ellipse, something like this. Sorry, it's an ellipse of this form. So remember that we need to fill the vector field with curves that will be orthogonal to V of R. So that means our field can be filled like this. Okay, but I'm not gonna draw here because this is very small for us to be able to see what I am talking about. So I'm gonna try to draw it as big as I can. So let me have this and then that. Okay, now what we do is we want to sketch the all. We're not gonna draw all the trajectories, but we're gonna draw as many as we can. Okay, so okay, the first trajectory is this one, so we're gonna draw this one, and know that we need, whenever we draw in the trajectories of a vector whenever we draw trajectories, we need to indicate the orientation. Okay, so to do that, let me draw this one here. So can be represented as okay, I'm not good at drawing, but I will try to be good. Okay, let me just draw two of them. It's not really important that you must draw two. You can go to 3 or 4, as long as you're gonna fill out, as long as it's more than one. I think so, as long as it's more than one. And then we have this one here. Okay, now we need to determine the direction. Now to do that, I'm gonna come here and then do something that we did while we were in high school. We know that in this quadrant here, on the first quadrant, we know that x is positive and y is also positive. Okay, on the second quadrant, we know that x is negative, y is positive. On the third quadrant, they are both negative, and on the fourth quadrant, the okay, x is positive, y is negative. Okay, this is what we did when we were in grade in high school. Let me not attach a grade to that. Okay, so having these, okay, let me write my equation. Let me write my equation here. So we have v is equals to minus 4y squared xy. Okay, and then take this one away and then bring this here, my drawing there. Okay, everything is there. Now considering this thing here, so we want to determine the direction of our curve, the orientation on the first quadrant. So we're going to use we're going to use what we know about the first quadrant. We know that x is positive and then y is positive. So okay, let me first determine the orientation of the x coordinate. So we know that y is positive, so that will give us a positive, but note that there's also a negative here. So for our curve, I'm gonna give them by make an arrow for the things that we need to for the direction that we need to determine. So for this one, we're gonna have a negative because y will always be positive, and then there's an encountering negative sign, so that gives us a negative. And then on this side, note that x is positive and also y is positive, so and then we get a positive here. Okay, so the direction of this is given as up and to the left, up to the left. Okay, so that means in this region our orientation is in this form. Okay, now going to the second quadrant, we know that x is negative, we don't have x here, y is positive. Okay, if we put y is positive here, note that we always have a negative in this part, so that means we're gonna have a negative here, and then in this case x is negative and then y is positive, so we're gonna have a negative also here. So with the negative, it is down and to the left, so the direction here is in this way, meaning that it is running this way. Okay, down to the left, down to the left. Now on the third quadrant, we don't have x on the x coordinate of our vector, and then y is negative, but we are squaring y, so it's going to be positive, and then we have an encountering negative here, meaning that the x is going to be negative, and then x is negative, y is negative, we multiply them, we get a positive, so negative positive. So with this we have something like up and to the left. So that means when you transfer this arrow onto our curve, we're gonna have something like that. Okay, and then on the fourth quadrant, which is our last quadrant, on y is negative, but we are squaring y, and that means y will be positive, and then there's an encountering negative giving us a negative coordinate. And then on this side, x is positive but y is negative. Positive multiplied by a negative, we get a negative. Okay, so that means our direction is in this way, and when we transfer this into our curve, we have something like this. Okay, note that they're like spreading like this and then like that. Okay, now this is what you have to do when you want to determine the direction. Okay, now we have to draw the orthogonal trajectory, because we were told to draw the actual trajectory and the orthogonal trajectory on the same set of axes. And then doing that, we know that we have ax to the 4, and we know that the graph of y is equals to x to the 4 is such that it is in this it is like this. Okay, and then here we have a. In this case here we have a, and then a can be either positive or negative, so that means we're gonna have orthogonal trajectories that will go that way or this way. Okay, remember we are filling the region, so they are more than one. Okay, Now let's take this one, just copy what we have here into our answer for part C. So what we're gonna have is gonna be something like this. It's gonna be something like this. It's gonna be something like that. And then because we said that this a here can also be negative, it's a constant. We don't know, we're not sure if it's a is positive or negative, but we want to draw all the possible orthogonal trajectories. This means that our curve can also take this route here. Okay. And then one thing about orthogonal trajectories, we do not show direction on them. Okay, so this is answer for part C. And I think that this is what we had to do for this question 8 for 15 marks. And then if you just do that, you get all the marks that you so deserve. Okay, thank you for watching. Check out videos where I'll be doing other examples on orthogonal trajectories and whichever section that I have to do. Okay, thank you for watching.